Hello Year 7 and welcome to what will be our final lesson on probability. I hope you're all doing well. I hope you've been managing this topic fine, and today we are going to look at something that you've probably met before at primary school, something called a Venn diagram, which is just another way of classifying data or using it to do a little bit of work on probability. If you've managed to print out one of my sheets, that's absolutely fantastic. If not, I would just be expecting you to copy this as a normal lesson. Don't forget to put a title and to put an objective down. Okay, let's get into it. So, if you're familiar with the Venn diagram, this is what it kind of looks like. It is an overlapping series of circles. For a simple diagram, it might be 2 circles. For a more complicated diagram, there might be several circles. Okay? And the way that this works is that each circle represents a specific set of data. Okay? I've said each circle represents a certain criteria. And then you might have pieces of data based on your 2 criteria that satisfy both criteria. In which case, they go in this section. Some people call it the overlap, but the actual technical term is the intersection. Okay? You might also get some pieces of data based on the 2 criteria that don't actually satisfy either pieces of data. And in which case, you put them in this rectangular section out the side. Okay? So let's take a look how this works in principle with an example. What I'm going to do in my first example is populate this Venn diagram with the numbers 1 to 10. So that's 1, 2, 3, 4, all the way up to 10. And the criteria that I'm going to use are 2 words that we met very, very early on this year. The concept of a prime number and also the factors of 10. So, remember, a factor is a number that divides something exactly, and a prime is a number that has exactly 2 factors, one in itself. So what I might just do here is just think about what the prime numbers from 1 to 10 look like, and what the factors of 10 look like using the numbers 1 to 10. So I'll just do a little list here. So let's go through my prime numbers first. Now, one thing to remember is 1 is not a prime number because it only has 1 factor. So the prime numbers are 2 because it can only be divided by 1 and 2. 3, 5, 7, not 9 because 9 can be divided by 1, 9 and 3. So those would be your prime numbers. And factors are the numbers that divide it exactly. And when we did these way back in September, October, we used something called a little factor bug or a factor tree to list some of these. So we'll have 1 and 10, and we often listed them in pairs because 1 times 10 is 10, so both 1 and 10 are factors of 10. And then there is 2 and 5. Now, the reason why I've just done this little list here, it's going to help me very, very quickly fill in the intersection, because the intersection of those numbers between 1 and 10 that are both prime and a factor. And we can see we have 2 of those. It is 2 and 5. So those ones can go in the intersection. Which were the other prime numbers? Well, I've already written 2 and 5. The other prime numbers were 3 and 7. So those go over here. So those are all my prime numbers. Now we've got the factors of 10. Well, I've already done 2 and 5 in the intersection. So the ones that I've got left are 1 and 10. Now, that diagram isn't quite finished. And the reason why it's not finished is because we were meant to be doing all the numbers 1 to 10. And I think there's some numbers missing that need to go on the outside, the numbers that are neither prime nor factors of 10. So let's just count from 1 to 10 and see what we've missed. 1, 2, 3, 4 must be out here, 5, 6 must be out here, 7, 8 must be out, 9, and we've already done 10. Now, once you've populated a Venn diagram, you can actually do some probability questions. And I'll just do a couple of examples at the side. And there'll be a couple like this in the exercise towards the end. Imagine that I was to pick a number between 1 and 10. What would be the probability that is a factor of 10? Well, we know there's 10 possible outcomes, so it's going to be a probability out of 10. And how many of these numbers are factors of 10? Well, let's count them. 1, 2, 3, 4. So the probability of a factor of 10 is 4/10, or 2/5. That's dividing numerator and denominator by 2. Let's just do one more probability question. So let's do the probability that I pick a number at random and it is an even prime number. So, in my Venn diagram, how many of those numbers are even primes? Okay, well it's still out of 10. And there is 1 out of 10 that is an even prime. For our second example, I thought we'd look at some shapes. Now, we would have perhaps done this in class without the second screen that I've just put up, and I would have gone through and explained some of the different types of quadrilateral, but I thought it was just quicker to put up a second screen so we can see the different types of quadrilateral that exist. So, the word quadrilateral just means any four-sided shape, and on this screen you can see I've managed to find something that shows 6 of the 7 different types of quadrilateral. Sometimes you have to go be a little bit careful when searching for quadrilaterals on the internet, because not all of the shape names are called the same in the UK as they are in the US, for example, and a lot of web-based websites use the US names for some of these shapes. So, for example, if you are doing a little bit of research on the internet on quadrilaterals and you come across the word trapezoid or trapezoid, don't really even know how it's pronounced, that is the American version of what we call a trapezium. Okay, so if you're interested, the one that's missing is a shape that's called an arrowhead or a delta, and it looks like that. So I might need to refer to that one in a moment. So we have 7 shape names to populate into this Venn diagram. And my criteria is all the sides are the same length. And the other criteria is that it has at least one right angle. So it has to have a 90-degree angle. Okay, I think the easiest thing to do here is start with the intersection and pop in those shape names that have all sides that are equal and have at least one right angle. So have a look at the diagram. How many of those shapes are all sides equal and have right angles? Well, I can only see one that satisfies that, and it is the square. So I'm going to pop square in the intersection. Are there any other shapes where all the sides are equal? So have a quick look. It is the rhombus. I often describe a rhombus as like a wonky square. Okay, a rhombus is the posh name for a diamond, but please avoid ever using the word diamond in maths. We call it a rhombus. Okay, are there any other shapes that have at least one right angle? Okay, I can see a shape that has a right angle. It is a rectangle. So that would go there. Now, all the other remaining shapes do not have equal sides, and they do not need to contain a right angle. So our other 4 shapes can be listed below. So we've got a kite, a trapezium. You can draw a trapezium with right angles, but it doesn't have to. What have we missed? A parallelogram. And a parallelogram is like your wonky rectangle. And then, of course, the one extra one that I've had to draw, that is the arrowhead. Okay. So I hope you've managed to follow my examples. There's going to be some questions very, very similar to example number 1, and then a slightly more challenging question based on finding some probabilities from your Venn diagrams. But for the time being, that's me signing out, and take care, and goodbye.